morning, dear students. This is Dr. Priya, working as Associate Professor in Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. So today we are going to learn about different units of expressing hardness of water and what is the relationship among those different units of hardness of water sample. So let us start with degree of hardness of water. As I explained in the previous class that hardness of water is purely due to presence of salts of calcium and magnesium that were present. Salts of calcium and magnesium like calcium bicarbonate, magnesium bicarbonate, calcium chloride, magnesium chloride, calcium and magnesium sulfates. Sometimes they may be present, all 6 salts are responsible, that means altogether they will present. Sometimes few will be present, or sometimes 3 to 4 salts will be present, or at least sometimes one salt if it is present. These are able to impart a property called hardness. So hardness of water, it is expressed in terms of calcium carbonate equivalence. If you notice the reaction that is involved when a water sample which is having temporary hardness is subjected to boiling, then it is able to convert into corresponding CaCO3 insoluble precipitation. That means temporary hardness, it is purely due to calcium as well as magnesium bicarbonate. We know very well. This on boiling, calcium bicarbonate on boiling, so it is able to convert into insoluble CaCO3, that is in the form of precipitation. Clearly, it is insoluble in nature, that means it is visible. So it can be easily removed by adopting filtration technique. Right, same CaCO3, that is calcium carbonate, we are going to adopt here for expressing the hardness of water sample. That means whatever be the type of salt that is present in dissolved state in water, during its purification or removal technique, we are finally going to convert that salts of calcium and magnesium into insoluble precipitates of calcium carbonate. So that's why we are going to express hardness of water in terms of calcium carbonate equivalence. So why we need to consider only calcium carbonate? Because so it is easy for calculation. If you notice the gram molecular weight of CaCO3, it is equal to 100 grams. It is equal to 100 grams. If you calculate a calcium carbonate molecular weight, so for calcium atomic weight it is 40, and then carbon 12, so it is 52, and then oxygen 16 threes, so altogether it will come to 100. So gram molecular weight of calcium carbonate, it is equal to 100. So it is easy for calculation part if it is like 100 or multiples of 5. Say for example, this is gram molecular weight of calcium carbonate, and similarly if it is gram equivalent weight, it is 50. So multiples of 5 like 50 or 100, these two will become easy for calculation. So that is first advantage when we are going to express this any salt that is present in the water sample in terms of calcium carbonate. And second one, it is an insoluble salt. As I told you, if you notice the reaction, that is calcium bicarbonate, simply on boiling the water, it is able to convert into insoluble precipitation of CaCO3. So it is insoluble in nature. So at the same time, it is PPT, that is precipitation. So this PPT, or we can call it as precipitate, it is insoluble in nature, can be easily removed by filtration technique. Simply by filtering the water, it can be separated. So that is second advantage why we are going to consider calcium carbonate. That means hardness, it is expressed in terms of calcium carbonate equivalence. What is the first plus point, or we can say advantage of CaCO3? Its gram molecular weight, it is 100, or we can consider its equivalent weight as 50. So both are easy for calculation part, for doing the problematic part. And the second advantage is it is an insoluble salt. It is not soluble in the water. So it can be easily removed by filtration technique. So, and the next one, it is classification of hard water on the basis of degrees of hardness. Say for example, if the water sample we identified or we noticed that the supplied water sample it is having 0 to 70 milligrams per liter, or we can express this one in ppm, parts per million. Both are equal. 1 ppm it is equal to 1 milligram per liter. So if that water sample it is having a range of hardness that is equal to 0 to 70 ppm or milligrams per liter, then it will be named as soft water. So it is named as soft water. As per our knowledge of definition of soft water, what do you mean by soft water? The water which is able to produce lather easily by consuming very little amount of soap. That is called soft water. That means presence of salts will be in very, very less amount or less concentration. So that's why it is having very little amount of hardness. See, if that presence of salts it is getting increased, that means their concentration it is getting increased. Concentration of salts of calcium and magnesium, if they are getting increased, then what will happen? Hardness also gets increased. So these two are directly proportional. Say, as I told you, if it is getting increased, see the next range, that is 70 to 150 milligrams per liter or ppm. So that one we will call it as moderate hard water. Again, if concentration it is getting increased, then hardness also proportionately it is getting increased, that is in a range of 150 to 300 milligrams per liter or ppm. So this is what we call as actually hard water. So once it is exceeding that 300 milligrams per liter or ppm or greater than, that means greater than or equal to 300 ppm or milligrams per liter, we will call such water sample as very hard water. Very hard water. So we are going to express the hardness of the water in terms of calcium carbonate equivalence. Why we are going to express this calcium, why we need to express this hardness of water in terms of calcium carbonate equivalence means, as I told you, when water it is subjected to boiling, we can expect the formation of insoluble salt of calcium carbonate, which is purely insoluble in nature. It can be removed by filtration technique. So in the similar manner, whatever be the type of salt of calcium and magnesium that is present in the water sample, during its purification or removal, it can be converted simply into insoluble precipitate of calcium carbonate. And moreover, its gram molecular weight it is 100 grams, its equivalent weight it is equal to 50, so that it becomes easy for calculation part while doing the problems and estimation. So and then as I told you, it is insoluble in nature, it can be removed by filtration technique. Next thing it is, so far what we have discussed, hardness of water. So this hardness of water it is expressed in terms of calcium carbonate equivalence. So that is weight of the salts that were present in the water sample. Say for example, calcium chloride, calcium sulfate, magnesium chloride, magnesium sulfate. Whatever be the type of salt that is present in the water sample, so it is going to convert. So what we are going to do, that one we are going to convert into equivalent weights of calcium carbonate, CaCO3 equivalent weights we are going to convert. So this is the logic behind expression of or expressing the hardness of the water sample. So how it can be converted? Say for example, I am telling that calcium chloride that is present in dissolved state in water. I just want to convert that calcium chloride weight in terms of CaCO3 equivalent hardness. So what is the formula that we are going to use? See the formula. Hardness of hardness causing salt in terms of CaCO3. So this we are going to consider. That means, say for example, calcium chloride if it is present in dissolved state in the water sample. So using this formula, so its amount, or we can say weight of that hardness causing salt will be given in the data, that is problematic part, that we have to substitute here, that is weight of the salt. Say for example, it is like 10 like that, if it is mentioned in the problem, that is data. So it is mentioned like 10 grams like that it is mentioned. So that means this 10 we have to substitute in the place of amount of hardness causing salt into 100. This 100 is nothing but gram molecular weight of calcium carbonate. As we need to convert any salt weight in terms of CaCO3 equivalents, we have to use a multiplication factor of 100. This 100 is nothing but molecular weight of calcium carbonate. So it is divided by gram molecular weight of hardness causing salt. That means gram molecular weight of calcium chloride. It is to be substituted. So in the numerator, weight of the calcium chloride that is given in the problem, in the data form it is given. It will be given. So that value you have to substitute here, divided by gram molecular weight of the same salt, that is calcium chloride, hardness causing salt, into 100. So this formula can be changed in another way. That is, say, amount of hardness causing salt, say for example, calcium chloride we have taken, that is weight of calcium chloride will be given in the data, that is in the problem. So that we will substitute here into, so instead of 50 we can substitute, instead of 100 we can substitute 50 also. 50 is nothing but gram equivalent weight. So this is 100 is gram molecular weight, it is mentioned here. So this can be replaced with 50 also. 50 is gram equivalent weight. So this can be used. This also can be used in the formula for finding out this or converting into CaCO3 equivalents, divided by gram molecular weight of hardness causing salt. If it is 50, we are going to replace this one. It is going to replace with equivalent weight of gram equivalent weight of hardness causing salt. Say for example, calcium chloride, in the previous case what we have considered, same example I am going to consider. In the problem, data is given like that. The following water sample it is having, so 10 milligrams of calcium chloride, it is present in dissolved state in 1 liter of water. That means amount of hardness causing salt CaCl2, how much it is given? 10 milligrams per liter. And then we have to calculate its gram equivalent weight. Gram equivalent weight of CaCO3 we have to calculate, and then amount here we have to substitute, divided by its gram equivalent weight, that is CaCl2 gram equivalent weight, into 50 gram equivalent weight of CaCO3 we have to substitute. So using this formula we can convert or we can express hardness causing salt's weight in terms of CaCO3 gram equivalents. And the next topic, it is units of hardness. So what are the different units that we are going to use for expressing the hardness? So there are 4 different types, 2, 3, 4. So what is the first one? ppm, short form it is ppm, parts per million or ppm. Second one, it is milligrams per liter or mg per L, liter. Next, third one, it is degree Clark, and the fourth one is degree French. There are 4 different ways for expressing the units of hardness. One is parts per million, first one, or ppm. Second one, it is milligrams per liter. Third one is degree Clark, and the fourth one is degree French. So let us learn about their definitions. What do you mean by 1 ppm, or how it can be defined? Parts per million, that is ppm. One part of 1 ppm, how it will be defined? 1 ppm it is equal to 1 part of CaCO3 equivalent hardness causing salt that is present in 1 million parts of water. 1 million parts means it is equal to 10 power 6. So 1 ppm can be defined as 1 part of CaCO3 equivalent hardness causing salt that is present per 1 million parts of water, that is 10 power 6 parts of water. So 1 ppm it is equal to 1 part of hardness causing salt expressed in CaCO3 equivalents present in 1 million parts of water, that is 10 power 6 parts of water. And 1 milligram per liter, 1 milligram per. So instead of using part here, we are going to replace with milligram. So 1 milligram per liter it is equal to, or it is defined as 1 milligram of calcium carbonate equivalent hardness causing salt present in 1 million of water, that is 10 power 6 parts of water. That means we know that 1 kg of water it is equal to 1 kilogram, it is equal to 1000 grams. So I am going to convert in terms of milligrams. So again we have to multiply with 1000. So this is 10 power 3 and this is also 10 power 3. So altogether it will convert to 10 power 6 milligrams. So I just want to convert 1 ppm, means 1 ppm it is always equal to 1 milligram per liter. That means what is the final conclusion? 1 ppm it is always equal to 1 milligram per liter. So they can be defined as 1 ppm or 1 milligram per liter. It is equal to 1 part of CaCO3 equivalent hardness causing salt present in 1 million, that is 10 power 6 parts of water. What is the third one? Degree Clark. So it can be defined as 1 degree Clark is defined as 1 part of CaCO3 equivalent hardness present per 1 gallon of water. 1 gallon means it is equal to 70,000 parts. What do you mean by 1 gallon? 1 gallon it is equal to 70,000 parts of water. 70,000 parts of water. Right. So 1 part of CaCO3 equivalent hardness present per 1 gallon of water. So 1 degree Clark it is equal to 1 part of CaCO3 equivalent causing hardness causing salt that is present in 70,000 parts of water. So here it is mentioned like 1 degree Clark is equal to 1 part of CaCO3 equivalent hardness causing salt present in 1 gallon means 70,000 parts of water. Next, what do you mean by 1 degree French? So 1 degree French it is equal to 1 part of CaCO3 equivalent hardness, but amount it is 10 power 5 parts of water, hard water. So in the previous case it is like 10 power 6 parts in the case of ppm and milligrams per liter. Now it is changed to 10 power 5 parts of water sample. So 1 degree French it is equal to 1 part of CaCO3 equivalent hardness causing salt present per 10 power 5 parts of water sample. So let us know about their relationship. Hardness of water can be converted into all 4 units when we know what is the interconversion between the all types of or we can say all units of hardness. So we know that 1 ppm it is always equal to 1 milligram per liter. So it is equal to 1 ppm or 1 milligram per liter, it is equal to 0.07 degree Clark, and that is equal to 0.1 degree French. So this is one type of interconversion table or formula. We have to keep it in mind while doing that numerical part related to determination or estimation of hardness of given water sample. Or if I know 1 degree Clark, I just want to convert in terms of French. Then 1 degree Clark it is equal to 1.43 degree French, and this is equal to 14.3 ppm. That means 1 degree Clark is equal to, in terms of ppm, it is equal to 14.3 ppm. Both are same. We know that 14.3 milligrams per liter. So we have to keep these interconversions in mind so that we can easily do the determination or estimation of hardness of given water sample. So in today's class, so far what we have discussed is degree of hardness, that means basing on the amount of hardness that is present, which is expressed in terms of ppm, what type of water we will call it as, like soft water, hard water, very hard water, like that. So after degrees comparison of hardness, then we discussed about units of hardness. There are 4 different types of units used for expressing hardness of a supplied water sample. First one it is ppm, parts per million. Second one it is milligrams per liter. Third one is degree Clark. Fourth one is degree French, and their interrelationship between all those 4, which is very much useful for problematic part. So in the next class, we will know how to estimate or find out the temporary and permanent hardness of the supplied water sample. So thank you very much. That's all for today's class.